Good morning, students. So yesterday we discussed the types of matrices: symmetric, Hermitian, unitary and orthogonal matrices, and we missed one very important problem which we are going to discuss today. Show that the following matrix is orthogonal. So we are going to show this matrix is orthogonal matrix or not. For orthogonal matrix, we have to use this formula A to the power T, which is equal to identity matrix. A transpose. So T stands for transpose. So what is a transpose? We are going to change the rows into columns into rows. So this is a given matrix, and A transpose is given by this because we have changed the rows into column into rows, and you are going to multiply these two, A and AT. So when you are going to multiply these two, so this is your A and this is your A transpose. When you are going to use the matrix multiplication, you will get this answer. So cos theta multiplied by cos theta will give you cos square theta, minus plus, so sin into sin theta, that will give you sin square theta. So for the next multiplication order, you will have this element, and the next one you will have this element, and the last one will be sin theta multiplied by sin theta will give you sin square theta, cos theta multiplied by cos theta will give you cos square theta. Of course, we know that cos square theta plus sin square theta equal to 1. So this becomes 1, and this will get cancelled, and this also will get cancelled, and this will become 1. So 1 0 0 1 will be the final answer. So your A transpose will be your identity matrix. So this matrix must be a orthogonal matrix. Okay. So in this class we are going to discuss the characteristic equation of a matrix, eigenvalues and eigenvectors of a matrix. So all these three things are very, very important, not only in mathematics but also in all the other subjects. So we are going to discuss today characteristic equation 1, and second one is eigenvalue, and third one is eigenvector. So what is a characteristic equation of a matrix? The characteristic equation of a matrix is a polynomial equation derived from the matrix, crucial for finding out its eigenvalue. So characteristic equation out of which we are going to get the eigenvalue, proper value for any matrix, and we can go with eigenvectors also. So eigenvalues are proper values. So we are able to get some solution, those from the matrix, using characteristic equation. The characteristic equation, the form of characteristic equation is det A minus lambda I equal to 0, where A is the matrix and lambda is some scalar function. Of course, I is an identity matrix. So we are going to use this equation, and this is nothing but a characteristic equation, and the solution of characteristic equation nothing but eigenvalue. So eigenvalues are very, very important. For example, when you take in quantum mechanics, eigenvalues are nothing but any the solution of any quantum systems we can find out. And many other subjects, eigenvalues are very important. What are the eigenvectors? Eigenvectors which will show the direction which remains unchanged. So it's like a scaling factor. So it is defined as the determinant of the matrix minus a variable times the identity matrix, which set is equal to 0. Setting this determinant equal to 0 defines the characteristic equation. So this is our characteristic equation. The solutions to this equation are the eigenvalues of the original matrix. Eigenvalues are important for understanding the behavior of linear transform. So whenever there is a linear transformation from one system to another system, you will be able to get eigenvalues as well eigenvectors. So linear transformations are very important. So when you are going to take in quantum mechanics, from one system to another system, there will be a linear transformation. So operations will be linear. So whenever there is a linear transformations involved, the eigenvalues will get the solution, and eigenvectors also will be there. So now find the characteristic equation of a given matrix. Okay. So this is 2 by 2 matrix. So find the characteristic equation of a given matrix. See, this is the characteristic equation of a matrix. 2 1 4 minus 6, and det A minus lambda I is the characteristic equation. A is given as this. So A minus lambda I matrix. See, 1 0 0 1. So that will give you 2 this will be minus lambda. Okay, so this becomes 2 minus lambda. Minus lambda multiplied by 0 is 0. So 1 will be there. Is it okay? Now 4 minus lambda multiplied by 0, that will give you again 0. So 4. And this becomes minus lambda. And already one minus 6 is there. So minus 6 minus lambda. Is it okay? So this is your a minus lambda I. Is it okay? So you have that a minus lambda I becomes 2 minus lambda 1 4 minus 6 minus lambda. So now you have to find out the determinant. So you have to find out the determinant. So when you are going to find out the determinant, you have to multiply this one. So 2 minus lambda minus 6 minus lambda. 4 multiplied by 1, that will give you 4. So minus 4. So now 2 6 are, so here 12, so minus 12. Then we have 2 minus lambda minus 2 lambda minus lambda minus 6, that will give you plus 6 lambda. Lambda multiplied lambda will give lambda square, so minus 4. Okay, so minus 12 minus 4, that will give you minus 16. So lambda squared is there, minus 2 lambda plus 6 lambda, that will give you 4 lambda. So this equation is the characteristic equation of a matrix, given matrix. So that's all. It's a very simple one. So matrix A is given. You are asked to find out the characteristic equation of the matrix. So we have obtained the characteristic equation of the matrix. The solution will be your eigenvalue. Okay, the solution will be your eigenvalue. Now second problem. Find the characteristic equation of the given matrix 1 0 0 1. So 1 0 0 1. Okay, so this is an identity matrix, correct? So use the characteristic equation a minus lambda I determinant. So 1 0 0 1 minus lambda 1 0 0 1 will give you this. So lambda minus 1 multiplied by lambda minus 1, lambda minus 1 whole squared minus 0. So you have lambda minus 1 whole squared, which is nothing but lambda squared minus 2 lambda plus 1, which is equal to 0. This is your characteristic equation. Now we will go for the next problem. Find the characteristic equation of the given matrix 0 3 minus 5 4. So a minus lambda is the characteristic equation. Use the characteristic equation and get this matrix minus lambda 3 minus 5 4 minus lambda. So take the determinant, that will give you minus lambda multiplied by 4 minus lambda. Okay, minus, already minus is there. Okay, one more minus is there, so plus 15. So multiplying with lambda, that will give you have lambda squared minus 4 lambda plus 15 equal to 0 is the characteristic equation. Now the last problem to find out the characteristic equation of the given matrix is 3 0 0 8. So a minus lambda is the characteristic equation. As usual, we are going to use a minus lambda I, that will give you this matrix 3 minus lambda 0 0 8 minus lambda, and simplifying you will get 24 minus 3 lambda minus 8 lambda plus lambda squared, and this is your characteristic equation of the given matrix. Very simple one. Lambda squared minus 11 lambda plus 24 equal to 0. Now see, these are all for 2 by 2 matrix, correct? We will go for now 3 by 3 matrix. So example 1, A equals 1 0 0 0 0 1 0 1 0. So you are going to find out the characteristic equation of this matrix. As usual, determinant a minus lambda I must be equal to 0. So this is your a minus lambda I. So simplifying, that will give you 1 minus lambda. See here, 1 minus lambda, correct? Other things are all 0 0 0, and here it is 0, and next one will be minus lambda. See, minus lambda, and the next one will be 1, and third row will be 0 1, and last one will be minus lambda. So we can have 1 minus lambda multiplied by minus lambda multiplied by minus lambda will give you lambda square. 1 into 1, that will give you minus 1. So simplifying, that will give you 1 minus lambda, lambda squared minus 1 equal to 0. So you have lambda squared minus 1 minus lambda cube plus lambda. So modifying, that will give you minus lambda cube plus lambda squared plus lambda minus 1, and this is your characteristic equation of the matrix, 3 by 3 matrix. Find the characteristic equation of this matrix. Okay, now this is 4 by 4 matrix. So very important thing is, we are going to find out only the characteristic equation will be obliged only for square matrices. See, for all 2 by 2, 3 by 3, 4 by 4. So we are able to get eigenvalues only for the square matrices. It will never go with 2 by 3 or 3 by 2 matrices, not rectangular matrices. Only for the square matrices it will work out. Okay. So now, as usual, we are going to find out the characteristic equation of this matrix. So A minus lambda I is a characteristic equation. Okay. So we can go with like this. So we have 5 minus lambda multiplied by 3 minus lambda, 5 minus lambda, 1 minus lambda. All the other things are not 0. You need not go for this operation. You can go for this operation. Okay. So you can go for this operation. See here. Instead of going this, so you'll have to go only with next one will be minus of minus plus 2, then another will be plus 6, then another will be minus of minus plus 1. So instead of going by this operation, we can go for this operation. You will get this. Okay. So the characteristic equation will be 5 minus lambda whole squared, 3 minus lambda, 1 minus lambda, which is equal to 0. So this is the characteristic equation of 4 by 4 given matrix. So find the characteristic equation of a matrix. So now we are going to have another method. So earlier we calculated the determinant. Okay, A minus lambda equal to 0. Now we are going to use this formula. So you have to learn by heart for this formula, and this will be worked out only for the 2 by 2 matrix. You have to learn by heart this formula. See, this is 2 by 2 matrix. We are going to find out the characteristic equation, but we are not going to follow the determinant method. We are going to follow using this equation, lambda squared minus S1 lambda plus S2 equal to 0, where S1 is the sum of main diagonal elements. Sum of main diagonal elements. What is this called? Yesterday we learnt sum of main diagonal elements. What is that one called? No. What is the term called? You are going to add all the diagonal elements. Sum of main diagonal elements. What is it called? Yesterday we discussed. Trace of a matrix. Trace of a matrix is you are going to add all the diagonal elements. So S1 is the sum of main diagonal elements. So S1, okay. S2 is determinant of a matrix. Of course, for 2 by 2 matrix it's very easy. So now A is given as 1, 2, 0, 2. So S1 is the sum of main diagonal elements. So 1 plus 2, which is nothing but 3. What is S2? S2 is a determinant of A. How to find the determinant of A? 1 multiplied by 2 minus 2 multiplied by 0. So the answer is 2. So we have found out the values of S1 and S2. You substitute here. So when you are going to substitute, you will get lambda squared minus instead of S1, 3, instead of S2, plus 2 equal to 0. So this is your characteristic equation. Instead of going for A minus lambda I equal to 0, we can go with some other method. So this is another method. Only thing is you have to remember this formula, lambda squared minus S1 lambda plus S2 equal to 0. This formula will work out only for 2 by 2 matrix. Okay, where S1 is the sum of main diagonal elements, S2 is the determinant of the matrix. Okay. Now, so now this is for 3 by 3 matrix. The formula for 3 by 3 matrix for another method is this one. For 2 by 2 matrix, the formula is this one. So you have to learn this formula. Okay, lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0, where S1 is the sum of main diagonal elements, of course, as it is there in 2 by 2 matrix. S2 is sum of minus of main diagonal elements. Very important, minus of main diagonal elements. I'll let you know. I'll discuss. S3 is the determinant of A. Okay, so S1 is very simple. S1 is the trace of a matrix. What is the trace of a matrix? Trace of this matrix 8 plus 7 plus 3, which is nothing but 18. Now S2 is sum of the minus of main diagonal elements. Very, very important. Minus of main diagonal elements. So this is first diagonal element. Okay. What is the minor? How to find out the minor? You just do like this. Remaining term will be 7 minus 4 3. So this is your that. Okay. Sum of minus of main diagonal elements. So this one. Now second one Second one, see, minus of main diagonal. This is the next diagonal element. 7 is the next diagonal element. What? How to find out the minor? See here, you just do like this. The remaining thing 8, 2, 2, 3. See, 8, 2, 2, 3. What is the other one? The next main diagonal will be 3. So just do like this. Then the remaining thing 8 minus 6 minus 6 7. So 8 minus 6 minus 6 7. So that is your next minor of main diagonal element. Is it clear? So this is the sum of minus of main diagonal elements. You have to take this element and this element. Sum of the minus of main diagonal element. Now it's easier to calculate now. 7 3s are 21 minus, so already one minus, so minus minus plus, so you have minus 16, and the next answer will be 24 minus 4, and next one will be 56 minus 36, that will give you 5 plus 20 plus 20, that will give you 45. Okay. Now what is the next one? S3 is the determinant of A. S3 is the determinant of A. So determinant of A, you have to find out the determinant. Okay. So A, which is equal to, as usual, you will have to find out the determinant. How to find the determinant? So you have to first multiply with the 8, multiplied by 7 3s are 21, 4 4s are 16, minus minus plus, so minus is there. So 21 minus 16, so this is nothing but 5. Is it okay? The next one will be minus 6, already your minus is there, so that will become plus 6, multiplied by, you will have to multiply this minus this and this, that will give you minus 10. The last one will be, so 2, you will have to multiply minus 6 multiplied by minus 4 minus multiplied by 7 multiplied by 2, that will give you 10. So 40 minus 60 plus 20, that answer is 0. So determinant equal to 0. If determinant of a matrix equal to 0, what is that matrix called? Yesterday we learnt the determinant of a matrix which is equal to 0. What is that matrix called? Not 0 matrix, 0 0 0, no, it's not like that. Determinant of a matrix equal to 0. Singular matrix. For non-singular matrix, determinant should not be equal to 0. Okay. So now your S3 equal to 0. S3 equal to 0. So substituting the values of S1, S2, S3, you will get this equation, which is nothing but the characteristic equation of the matrix A. So this is very simple. So 3 by 3 matrix. Show that this matrix satisfies its own characteristic equation. So this is 2 by 2 matrix, correct? 2 by 2. So you have to use only that formula, lambda squared minus S1 lambda plus S2 equal to 0, where S1 is the sum of main diagonals. So 1 plus 1 2. What is S2? Determinant of the matrix. Determinant of the matrix is 1 multiplied 1, already 1 minus is there, so plus 4. So 1 plus 4, which is equal to 5. So det A equal to 5. So substituting the values of S1 and S2, we have lambda squared minus 2 lambda plus 5, which is equal to 0. So this is the characteristic equation. Instead of going for A minus lambda A det equal to 0, we can go using this formula. Okay, it's very simple. Now to prove, see here, show that this matrix satisfies its own characteristic equation. Look at the word. Show that this matrix satisfies its own characteristic equation, whether it satisfies this characteristic equation or not. The question is different. So it is not asked to find the characteristic equation. It is asked, it satisfies whether it satisfies the characteristic equation or not. So for that, what you are going to do is change lambda into A. Change lambda into A. So you have A squared minus 2A plus 5y equal to 0. Correct? A squared minus 2A plus 5I, which is equal to 0. Okay. Now we know already A is here. A is given. So A squared minus 2A plus 5i. 5i is nothing but 5005. So squaring this, so 1 minus 2, 2, 1, that will give you this, minus this one and this one. So when you are going to have the matrix multiplication, you will get this answer. When you are going to add these two, you will get this answer. See, minus 2 plus 5 will give you 3. Minus minus plus 4. So plus 4 plus 0, that will give you 4. Here minus 4, 0. So minus 4. Minus 2, 5. Minus 2 plus 5 will be 3. Plus 3. And we are going to multiply, the matrix multiplication will give you this answer. Now we are going to add these two. When you are going to add these two, that will give you minus 3 plus 3, that will be 0. Minus 4 plus 4 will be 0. 4 minus 4 also 0. Minus 3 plus 3 also 0. So you will get 3, which is right hand side. See, it's the right hand side. Okay. So it implies that it satisfies the characteristic equation. So this matrix satisfies its characteristic equation. Okay. So verify the matrix. So we have already seen, correct? This sum is repeated or not? No, this is different. Okay, 1 to 2 minus 1, whether it satisfies its own characteristic equation, and we are going to find out. So we have to use this formula, lambda squared minus s1 lambda plus s2 equal to 0. S1 is the sum of main diagonal elements. So 1 minus 1, answer is 0. S2 is determinant of the matrix. So you have to find the determinant. So 1 multiplied by minus 1, minus 2 multiplied by 2. So that will give you minus 1, minus 4, minus 5. Substituting the values of S1 and S2, we have lambda squared minus 0 lambda minus 5 equal to 0. So we have lambda squared minus 5 equal to 0. So this lambda should be replaced by A, correct? Because we are going to find out whether it satisfies its own characteristic equation or not. So a squared minus 5y equal to 0. So your a squared is there, minus 5y, a multiplied by a minus 5y. So that will give you this matrix will give you 5005 minus 5005. The answer is 0. This is nothing but your right hand side. So the given matrix satisfies its own characteristic equation. Now what is another question? And hence find a to the power 4. So we are going to find out a to the power 4. The first one is we are going to find out its own characteristic equation or not. The second one is a to the power 4. So a to the power 4, which is that can be written as, we know already a squared equal to 5y, correct? A squared minus 5y, you bring this term to that side, that will give you a squared equal to 5y. A squared equal to 5y. Now a to the power 4 can be written as a squared multiplied by a squared, correct? So a to the power 4 equal to a squared multiplied by a squared. So let it be a squared. A squared is already 5y, and a squared already we have found out. See here, 5005 multiplied by this is your 5y. So multiplying these two matrix, that will give you 25 0 0 25. Is it okay? So we have found out now a to the power 4. Similarly, you can also find out a to the power 8 or a to the power 16. So whatever may be the matrix to the power, that we can get out of this formula. Okay. Now eigenvalues and eigenvectors. So one part is over. So we said we are going to discuss three things. One is characteristic equation. The next one is eigenvalue, and third one is eigenvector. Okay, eigen means proper. We are going to get the solution from a matrix, and this solution can be used elsewhere, everywhere, in all the other subjects. Especially in quantum mechanics, we can find out the eigenvalue of any quantum system, which is a proper system. Eigenvectors are special vectors that when a linear transformation is applied. So for any quantum mechanical system, we are going to have only the transformation from one system to another system will be always linear transformation. Whenever there occurs a linear transformation, there will be only a change in scale, not direction. Okay, there will be a change in scale, not in direction. We will discuss what is scaling. So this is a scaling factor after 2 minutes. The scalar factor by which they are scaled is called eigenvalue. We are going to discuss what is the scaling factor in 2 minutes time. Essentially, eigenvectors are the directions that remain unchanged or only scaled during a transformation, while eigenvalues represent the scaling factor. So eigenvalues are scaling factors, whereas eigenvectors show the directions which remain unchanged. An eigenvector of a square matrix A is a non-zero vector x such that Ax equal to lambda x. So this formula we are going to use, Ax equals lambda x, where A is a matrix, x is the eigenvector, lambda is the eigenvalue, x is the eigenvector. I repeat, A is a given matrix which operates on eigenvector, eigenvector, which is equal to lambda is a value, eigenvalue, with the eigenvector. If both are the same, x, here also we have x, that side also we have x, if both are the same, then we can say that this is an eigenvector, this is an eigenvector. If they are not same, then we can say simply it's a vector. Okay, so Ax equal to lambda x, it is an eigenvalue equation. Ax equal to lambda x is an eigenvalue equation. A stands for a matrix, given matrix, x stands for eigenvector, which is equal to lambda. Lambda is the eigenvalue, x is nothing but eigenvector. So A operates on eigenvector will give you lambda times the eigenvector, where lambda is a scalar called eigenvalue. This means that when a matrix A is multiplied by the eigenvector x, the result is a scalar multiple times of x. Okay. So let A equal to Aij square matrix, for example. Suppose there is an n-dimensional non-zero columns vector x such that the action of A on x will give you a vector which is just a multiple of x. So lambda times x. Okay, where lambda is a scalar product. In other words, the transformation represented by the matrix A just multiplied by the vector x by a scalar lambda. The vector x is then called the eigenvector of matrix A. Lambda is called eigenvalue of A corresponding to the eigenvector x. So very important, this was very important equation, and this equation is called eigenvalue equation. A is a given matrix, x is a eigenvector, and lambda is a eigenvalue, very good, and x is a eigenvector. Okay, lambda is a value, number. For example, we have A is equal to lambda x. As I said, this is an eigenvalue equation. So A minus lambda times x equal to 0. You can write like this. Okay. Now, for example, you just take a matrix A. 4, 6, 1, 3. You just take a matrix A. And this is eigenvector 6, 3. Now, you have matrix multiplication. You can have matrix multiplication. 4 multiplied by 6 plus 2 multiplied by 3 will give you 30. Similarly, 1 multiplied by 6 plus 3 multiplied by 3, that will give you 15. See, you just make this term exactly equivalent to this. You try, we'll try. This is Ax equal to lambda x, correct? Lambda is a number. As I said just now, lambda is a number. So this is your A, this is your x, which is equal to lambda x. So this must be your lambda x, correct? But here 6, 3 is your x. Now how to get 30, 15 for x? You just take 5 from here. So this can be written as 5 times 6, 3. Say 5 6 are 30, 5 3s are 15. So this is your lambda. Is it okay? So Ax, which is equal to lambda times x. See? So this is an eigenvalue equation. See, both are equal. See here, 6 3 6 3. This is an eigenvector. Is it okay? So Ax equal to lambda times x. Your lambda is 5. So what does it mean? Whenever you have a linear transformation from one system to another system, and this will enlarge, 5 times. Here it enlarges with 5 times. So 5 times. See here, 5 times it enlarges. Is it okay? So eigenvector represents the direction. Eigenvalue will give you a scaling factor. How many times it enlarges? Not only enlargement, but also it can shrink also. It can shrink. So it can reduce. Not only it will increase, it will also decrease. So scalar factor will decrease. So eigenvalues and eigenvectors are crucial for understanding how a linear transformation affects a vector. Okay, they help to identify the directions in which a linear transformation stretches or shrinks. It can stretch or shrink a vector while maintaining its direction. Okay, it remains, the direction will be unchanged. Eigenvalues. To find the eigenvalues, we will have to solve the characteristic equation, which is equal to 0, where A is a matrix and lambda is the eigenvalue, I is the identity matrix.